Hey guys, welcome to Unit 6, Lesson 3, Solving Log Equations. I want you to pause the video and try the do now on your own. So the do now, it says, part A, says write in exponential form. So anytime you're writing in exponential form, we write to, I always say circle the base, run the race. So what's your base here? That's natural log means log base E. So I'm going to rewrite it if anyone's confused. Natural log is log base E x. It's the same thing. So circle the base. Your base is E to the y equals x. So this is going to be E to the y equals x. So the next one, we're saying write it in log form. If you're writing in log form, the first thing we need to do is write it as write log. What's my base? Base is 10. Remember, the exponent is always equal to the output of the log, and it is 10,000. That's what it's going to be. Expand. Whenever you're expanding, just see number of variables. I have 1, 2, 3 variables, and you're going to use your properties that we learned in lesson 2 to expand. So I'm going to write log. I'm going to write log with each of those variables. A to the 5th. Subtraction, division changes to subtraction. Log square root of b, and this would be, I'm going to put this in parentheses, but c was plus log c cube. Now this 5, the exponent goes in the front, so it'll be 5 log a minus square root is same thing as saying 1/2, so I'm going to bring that 1/2 to the front, so 1/2 log b. Remember, I'm going to distribute the negatives, so if I'm distributing it, it'll be minus 3 log c. That's how you expand it. Now when you're condensing, you're doing it backwards, so these numbers in the front become the exponent, right? Addition becomes multiplication, subtraction becomes division. So I'm going to write it as 1 log. I'm just going to do both steps. So this is 1/2 plus log b to the 1/2 minus log c cube. Now I'm going to condense it. So log, write log once. Addition changes to multiplication. So it's a times b, and it would be square root over c cube. You can choose to put it in parentheses or just leave it like that. So these are a few steps that I wrote down. I want you to copy them on a separate sheet of paper so that they help you when you're solving log equations, because you would need them for both your lessons 3 and 4. So solving log equations. When you get a log on one side of an equation, you always convert to exponential form and solve. For number 2, logs on both sides. If you have logs on either side of your equal sign, you can cancel the log and solve the equations as you would do. If they're quadratics, you'll solve by factoring. If they're linear, you'll solve it by isolating the variable, and so on. Number 3, no logs and the variable is in the exponent. So whenever your variable is in the exponent, it is an equation like, I'll just give you an example, 2x to the 5th, right? If you could make the bases same, you would make the bases same, but if you cannot, then you end up taking logs on both sides and solving them. Number 4, more than one log on either side or both sides. So in this scenario, you will condense each side to 1 log and solve. Always check your answers, and no matter what kind of answers you get, always put them back into the original equation and check and look for those extraneous roots. When we do those questions, these steps will make more sense. So let's get started with the lesson. First one, I hope you all copied the notes and they are in front of you. So the first one, you see a log on one side. Doesn't matter whether it's a common log, which is base 10, natural log, which is base e, or log to any base. You solve all the equations, all the log equations in the same format. So here it is ln. Basically ln is what? Log base e. So what did we say? If you have log on one side, we convert into exponential form. So what's the base here? E to the fifth equals 2x minus 1. And we are rounding all our answers to the nearest hundredth. Hundredth means 2 decimal places. So e is a number. So I'm going to solve for x. So I'm going to add 1. I wouldn't put this in the e to the fifth in the calculator. And I'll just wait for the final answer and then put it once in the calculator. And then divide by 2. So x is equal to e to the fifth plus 1 over 2. Put this whole thing in the calculator and you will get x is equal to 74.7065. You want to round to the nearest hundredth. So this is your hundredth place. You look at the number next to it. If it is 5 or larger, you round up. So this would be, since it's 6, it will be 74.71. As I said, you must always check your answer. So I'm going to take this 74.71, substitute in here 2 times 74.71 minus 1. This number should never be negative. If it is negative, then that is an extraneous root. If I substitute in 74.71, it's going to be a larger number. It's not going to be negative. It's going to be a larger number than 0. So this is good. Okay, let's try number 2. Here again, log is on one side. So what do? Convert to exponential form. So your base is 3. Circle the race, run the race. 3 to the fourth equals 5x plus 6. Yep, it's that easy. Very straightforward. 3 to the fourth is, it's not 3 times 4. It's 3 to the fourth power. So 3 times 3 times 3 times 3. You can use your calculator or just remember your powers of 3. 3 to the fourth is 81 and the right side is as it is. It's a linear equation. So I'll get subtract 6. I get 5x equals 75 divided by 5. I get x equals 15. Again, take this 15 and substitute in here. 5 times 15 is 75 plus 6 is 81. So that is a positive number. This whole number is positive, so this is good. I want to do number 5. So again, I see log on one side, but I also see a number in front of the log. You have 2 things to do with it. Either you can divide by 4 or make it the exponent. I'm just going to divide it by 4 and get rid of it. Either or way would be fine. So divide by 4. This cancels. What am I left with? Log x minus 6 equals 11 over 4. You can simplify. Don't change it into decimal. Leave it in this form. So now, again, log is on one side. So what's your base here? This is a common log. Common log has a base of 10. So circle the base and run the race. You run to the opposite side of the equal sign. So this would be 10 to the 11 fourths equals x minus 6. Again, don't put this thing in the calculator. Wait, solve for x and then put the whole thing in the calculator at once. Add 6, you get x is equal to 10 to the 11 fourths plus 6. Now put this whole in the calculator, and what do we get? We get 568. X is approximately 568.34. Put this in the check whether it's a solution. So if I put 568, any number greater than 6 will make it positive. So this is true. So this is a good solution. Okay, I also wanted to do one last one. Number 15. So number 15 is when you see logs on either side of the equation, all you do is, what did we say? If you have log, the bases are same, you can just cancel them and you're just left with 2x minus 5 equals x minus 1. I just set it up for you. You can finish that. So finish the remaining of the questions. Good luck.